Okay guys, we'll just go into the next lesson and we'll just finish a little bit earlier instead. That way you can have a longer break. You have bio next, isn't it?
Yeah.
Okay. So what we want to have a look at now Okay, so to start with, I'll give you a small example just to give you an idea first. So suppose we have something like 1 over x plus 1 plus 1 over, I don't know, 2x plus 1. If you want to add these together, you multiply the bottoms, and then we do a cross and a cross. So we have 2x plus 1 times 1 plus x plus 1 times 1. What's wrong? So here we get 2x squared plus 3x plus 1, and on the top we'd get 3x plus 2. So going forwards is easy. It's not difficult to go from here to here. But what is difficult is to go backwards. Now why would we be interested in going backwards? Well, the reason is, if I ask you to do this, it's too difficult for you to do. However, if I ask you to do this one, it's very easy to do, because each of these will be logs, because these are both in your formula book. So that's what this is called. This is called a partial fraction. It's a much easier form than this form here. And the word proper means when the power up here is smaller than the power down below. Okay, so this is proper because the power on 3x is smaller than the power on 2x squared. 1 is smaller than 2. So for this lesson we'll only be dealing with proper partial fractions. So let's have a look at an example. How we can go backwards. Okay, can I scroll down? Yep. Okay, so if you take, for example, something like minus 12 over 3x squared plus 8x plus 4. The first thing you need to do is to factorize the denominator. Okay, so factorizing the denominator, here I should have 3x
Plus 2.
Yeah.
And x plus 2.
X plus 2. So this makes us think that the answer will be A over 3x plus 2 plus B over x plus 2. It should look something like this. If you go back to my example, when we get something like this when we have two things added together like this. In my example I had a 1 and a 1 here. But anyways, we think that my question can be written in this form. So now the real question is, what is the A and what is the B? Now there's two ways of doing this, of finding the a and the b, so I'll show you both ways. The first way of doing it is just multiplying all these 3 by 3x plus 2 and x plus 2. So I multiply this one as well by 3x plus 2, x plus 2, and I multiply this one as well by 3x plus 2, x plus 2. In other words, the two factors. That cancels that. That one there cancels that one there. And in fact, all of this cancels all of this. So you end up with minus 12 should be the same as a x plus 2 plus b 3x plus 2. Now the reason I changed my symbol into this is because this symbol here doesn't quite mean equals, it means equivalent. It means you're rewriting it. Okay, so I give you a simple example on the side here. It'd be like me saying 2x, well that's the same thing as x plus x. So that's what it really means. So what I'm saying is, I should be able to write this as these two here. Okay, so how does that help us? Well, at least it's not a fraction. It's saying, come on, wake up. You're dozing off there. Do you need to go out for a minute and come back? No, are you sure? Okay, so how does this help us here? Well, if this is true, then it should... Oh, why are you late? Come on, sit down. If this is true, then that means it's true for all x. So again, if I go back to the left, is this true, this statement? Yes. Should it be true for all values of x? Should be, shouldn't it? 2 times 5 is 5 plus 5. Okay, so likewise here, if this is true, then it's true for all values of x. Okay, so that means, therefore, it's true if x equals minus 2. Now you said, well, why did you choose minus 2? Because it will make this piece disappear. And this will be minus 6 plus 2. Sit down. So this is minus 12 equals minus 4b. So then b equals 3. Okay. Now, the second one we can get is, therefore, it's true if x equals minus 2 over 3. And the reason for this is it will make this piece disappear. So you get minus 12 should equal a times minus 2 over 3 plus 2, and then the next piece is 0. So you get minus 12 equals a times 4 over 3. Yeah, that's right, isn't it? So we get 4, 3, minus 9. Is that right? So therefore a equals minus 9. Yeah. So I have the a and I have the b. Now one way we can check this okay, so can I scroll down? So we think now that minus 12 over 3x squared plus 8x plus 4, we think that should equal a over, what was my first factor I had? 3x plus 2 plus b, and what was my second factor? x plus 2. Okay, so one way we could check if we got the right answer is we can add these two together and see if we do get this back here in the question. So just to save time, since we know how to add fractions together, we'll just put it together and derive. So can you tell me what was the first fraction? What was the A? Minus 9 over 3x plus 2 plus x plus 2. Like this? Okay, so let's see if we get the same thing. Yeah, I do. It's just it didn't multiply out the bottom, but yeah, it is the same thing. Okay, so we have an example there. Now I said there's a second way to do it, so what I'll do is I'll do another example, but I'll show you the other method you can use to find A and B. I prefer the other method. There's one I don't like this method here, and there's a reason for it. I wonder if anyone thinks what's bad about this method. Any problems with this? Doesn't seem like there's any big problems with it, but what I don't like about this method is the value I used for x is minus 2 and minus 2 over 3. And if I go back to the question up here, what values of x can I not use in this fraction? Those values that I did use later. So I don't like having to do that for these questions, because really I should say x is not this number and x is not this number. So later, when I said this is true for all values of x, I really should have said this is true for all values of x except the two values which I used. And this is a fact that's kind of glossed over in this method, but it still ends up working. The second method doesn't have to worry about this problem, so I'll show you how to do it the other method. So we'll take the second one as an example. Now I know this question looks actually more difficult, but if you can compare it to the last one, it's still the same type of problem. You still have a linear equation over a quadratic equation. So in fact, although it looks more complicated, it is exactly the same as the last example. So we start off by factorizing the denominator. Yeah, so what factors do you get here? (5x minus 6) and 9x plus 7? Okay. So we think that this fraction here I should be able to write it as a over 5x minus 6 plus b over 9x plus 7. So far it looks the same. And in fact, the next step is the same also. We multiply by the two factors. So just to save space, I'm not going to write them in, but the same thing happens. All of this cancels with both of these. The first one cancels with the first one, and then the second one here will cancel with the second factor, just like in the last example. So we end up with this. A, 9x plus 7, plus b, 5x minus 6. So far, still looks the same. Now this is where it gets a bit different. Minus 22x plus 62 equals 9ax plus 7a plus 5bx minus 6b. So I get minus 22x plus 62 equals 9a plus 5b x plus 7a minus 6b. Now I deliberately did this, and I should really have my tree symbols here. Okay. Now, I deliberately put the colours in to help you see what's going to happen next. On the left we have a linear equation, and on the right we also have a linear equation. The only way two linear equations can be the same is if all the coefficients are the same on both sides. So on the left we have 22x's, and on the right, therefore, we should have 22x's as well. So in fact, this problem here of finding the a and the b can be rewritten as solving this problem. 9a plus 5b equals minus 22, and 7a minus 6b equals 62. So now it just becomes a simultaneous problem. Okay, did you write those two equations down? Yep. So because this is just a simultaneous problem, and because we have 4 methods to solve this, and because we've done in semester 1, I'm not going to go through the trouble of solving these two. I'll just put the two into derive and get the answers. Or do you have them already? Yeah, you can give them to me here. So what did you get for A? Minus 2, and B?
2, and B minus.
So it's 2 and minus 2 then?
Minus 8.
Oh, minus 8, okay. So that's the A and the B. So you haven't finished. Yeah. Yeah. Ah, yes, we choose the values of x. We can choose any values of x, that's the first thing, okay? And what we do is we deliberately choose values that make one of these pieces 0. So if I choose x equals minus 2, it will make this piece 0. And if I choose x equals minus 2 over 3, it will make this piece 0. So we can choose any value of x, and we deliberately choose values that make them 0. Okay? So what are the advantages and disadvantages here? Well, the advantage of the second method is I never have to use values of x I'm forbidden to use. So that's a big advantage. But the disadvantage here in the second method is that it's longer. The advantage in the first method is it's shorter, but the disadvantage is I feel like there could be a potential problem. In the exam, however, which is most important for you, both methods always work and both methods are accepted in the exam. So it's not something to worry about too much. Just choose whichever method you prefer. And in fact, there's probably other methods as well, but these are the two I see the most. Okay. Now let's do another example, one that's very similar to this, but there's a small complication in it. So if I scroll down, minus 6x plus 22 over x squared minus 10x plus 25. So before you start, what type of problem is this? Well, it's linear over quadratic. And what were the two examples I've done for you so far? Linear over quadratic. So it seems like, what should be the problem here? So first, get me the factors of the denominator. What are they? Which is?
Minus 5.
Or if you prefer, if I write it as 2 here, you get this. Okay. So this makes you think, sorry, plus 5, is it? No, minus 5, yeah. So this makes you think, okay, so then is this a over x minus 5 plus b over x minus 5? Well, the answer is no. Because if I have a over x minus 5 plus b over x minus 5, what's that? That's a plus b over x minus 5, which just is basically a number over x minus 5. Now, is that what you have here? No. No, you don't have a number over a linear. What do you have? You have a linear over quadratic. So the problem is, okay, so what do we do when we have two that are the same? This seems to be a problem. How do we make the second piece? Okay. So this first piece is still right. There's nothing wrong with that. The problem is, how do we make the second piece? And the answer is, the second piece will be whatever is here squared. Okay. So if you have x minus 5 repeated, you first have it appear once, and then you have it appear twice. But there's still a problem here. I'm not exactly sure what to put. In fact, if we put B, it will work. So for the moment, I'm going to put B, but I need to come back and talk a little bit about this choice of B here. Yeah. Okay, so we now have minus 6x plus 22 over x squared minus 10x plus 25 equals a over x minus 5 plus b over x minus 5 squared. We do our multiplication trick. We get minus 6x plus 22. So what I'm doing is I'm doing x minus 5, 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 x minus 5. So that cancels all of that. The first with the first, well, they're both the same, and both of these with both of these. So you get a x minus 5 plus b. So I get minus 6x plus 22 equals ax minus 5a plus b. Minus 6x plus 22 equals x plus so it's the same thing. I can make my two equations. I get a equals minus 6, and I get minus 5a plus b equals minus 122. Oh, sorry, positive? So if I put my a in here, I'll get 30 plus b equals 22, so then b equals minus 8. So I have my a and my b. Okay, can I'll just switch screen for a moment. Well, actually, before I do. So, remember earlier I said, okay, we have our B here, and this seems to work, and it does work, but I have to talk a little bit more about my choice of B here. Okay. So you notice that in my denominator, for example, I had the same thing twice. So in other words, my denominator had something like this. Let me just make it case sensitive. Okay, so I had a over x plus a plus b over x plus a squared. And when I simplify this, I get a linear over quadratic, which is what my question was, okay? But what happens if I replace this b with something like bx? If I add these together, I still get a linear over quadratic. So it seems like I have another answer here, possibly. And in fact, if I replace this with bx plus c, and simplify this as well, I still get a linear over quadratic. So it looks like I have three possibilities here. In my example, I just chose b, but I could have had bx, or I could have even had bx plus c. So then the question is, okay, so how do we choose the top? It's not always just a number. It could be something more complicated. So I'll give you a very, very simple rule. When you split these up into your pieces, if this is a linear, then this should be a constant. And here in this example, if this is a quadratic, so you've got a quadratic here, this here on the top, for example, should be a linear. Okay? But if you've got a quadratic whereby the roots are repeated, like with a square, so you've got something which was, I'll just write or for repeated. It's still a linear on the top, but there's an important note. It should be a smaller linear. So what I mean by that is it could be just a constant or just a constant times x. It's very unusual that it's bx plus c. Now in fact, if we did this question again, but instead of bx I had bx plus c, you would still get the answer. The only problem would, not the only problem, what would happen is you'd end up getting b equal to 0 and c equal to minus 8 if you went with bx plus c. What do we do for the exam? Usually for the exam there's some hint in the question that will let you choose the correct numerator. Not always though, but usually. But my rough rule here is we should always choose a numerator that is 1 power lower than the denominator. And in situations where the denominator is something repeated, it's still 1 power lower, but it's usually something smaller, like just bx or just c. But if you wrote in bx plus c, you can still get to the answer. It's just more difficult. Okay. So let's look at more difficult examples now. So let's take something like 48 over. Yes, we'll get to it yet. 512x cubed plus 1088x squared plus 632x plus 63. In the exam, they don't expect you to factorize the cubic. In fact, they usually give you the factors. So for the class, you can use your calculator to factorize the cubic. I think it's mode 54. So can someone just give me the 3 factors here for this cubic? So it'll be mode 54 on the calculator. So it's factors, minus 1 over 8, so that'd be 8x plus 1. Yep.
8x plus 7.
Say again, sorry?
8x plus 7.
Yep.
8x plus 9.
Okay, so this can be written as 48, and just to save time, I'll just write cubic for short, for the full cubic, equals a over 8x plus 1, plus b over 8x plus 7, plus c over 8x plus 9. Again, we do our trick of multiplying by the 3 factors. So this cubic will cancel all the 3 factors. The first cancels the first, the second cancels the second, and the third cancels the third. So you'll be left with 48 equals a 8x plus 7 times 8x plus 9 plus b 8x plus 1 times 8x plus 9 plus c 8x plus 1 8x plus 7. Okay, I think the method I'll use here is by choosing x. So what I'll do is, if I was to make x equal to minus 1 over 8, this piece would go, and we'd be left with this. So you'd get 48 equals a, and this would be minus 1 plus 7 times minus 1 plus 9. So then a would equal 48 over 6 multiply 8. Is that just 1? So So I have a as 1. Okay, what should I choose next for x? Minus 7 over 8. So that piece would go, and I'd be left with this piece in the middle. So that is 48 equals b minus 7 over 8. So that would be minus 7 plus 1 times minus 7 plus 9. So then b would equal 48 over 6 times 2. Is that right? So is that 4? Yeah, 4. Did I lose a minus? Where did I lose my minus? Minus 6. Is this minus 6? Oh yeah, of course, sorry, minus 6 and 2, thank you. So minus 4. Okay, my last one, what should I choose for x? Sorry, you can't quite see that. I'll do it in, right. So what should I choose for x last? Minus 9 over 8. So that piece would go, and I'd be left with 48 equals c minus 9 plus 1 times minus 9 plus 7. So c would equal 48 over minus 8 times minus 2. Yeah? So what's that? 3, is it? Is that a 3? Yeah. So you have the A, B and C now. So you can say 48 over 512x cubed plus 1088x squared plus 632x plus 63. That equals 1 over 8x plus 1 minus 4 over 8x plus 7 plus 3 over 8x plus 9. Okay, so we'll have a look at another example now. Okay. I can scroll down? Yeah. Yep. Okay. I'll scroll down now. So H, I'll do this one as an example. Yeah, okay. So we have 16 x squared plus 65x plus 18 all over 28x cubed plus 36x squared plus 15x plus 2. Okay, so first, let's factorize the cubic here. So can I have the factors, please, for the cubic? 1, 2, and 3.
7x plus 2.
Yeah.
2x plus 1.
Yeah. Now, you see, this is the thing. You only get 2 factors. So that means one of the other factors is repeated. So which one is repeated? Is there any easy way to tell? Well, if you just think about it, if this one was repeated, what's 2 squared? 4. And we need a 2 at the back. So it can't be that one. It must be this one. What's 1 squared? 1 times 2 is the 2. So it must be the second one that's repeated, not the first one. Okay? So I have my three factors. So this is a problem that we've seen earlier where the factor is repeated. And we know how to take care of this. So this is 16x squared plus 65x plus 18 all over 28x cubed plus 36x squared plus 15x plus 2 equals a over 7x plus 2 plus b over 2x plus 1. And then when we have a factor that's repeated, we repeat it, 2x plus 1 squared. But this time I'm going to do it more fully. This is linear, so this should be constant. This is linear, so this should be constant. This is quadratic, so up here should be linear. So it's always one power less. But we know, say again? Because it's a quadratic rather than it's repeated, yeah. So because this is actually a quadratic, then it's a linear in the numerator. It's always a power lower. But because it's repeated, I know that one of these will end up being 0, probably the C. Although sometimes in the exam it will end up being the D. But I know that one of these should be 0 as well because this is repeated as well. Okay. I don't know which, but we know one should end up being 0. Okay, so the trick again is the same. We multiply by the three factors. 1, 2, 3, 1, 2, 3, 1, 2, 3, and then 1, 2, 3. So the entire cubic cancels all three factors. The first cancels the first, the second cancels the second, and these two cancel the two at the back. So you end up getting 16x squared plus 65x plus 18 equals A 2x plus 1 squared plus B 7x plus 2 and then 2x plus 1, and then the last one is plus cx plus d times 7x plus 2. Okay, so here we have 16. Yeah, well actually let's do it by choosing values for x. Okay, so what value for x should I choose first? Well, let's see what would be handy. Yeah, if I choose x equals minus, if I choose minus a half though, what happens is this one goes, this one goes, this one stays. Yeah. Where? Which one are we talking about? First, second, or third? It should have 7x plus 2 only, because this cancels two factors because of the square. These three brackets here are these three here. So the square cancels the back two. Yeah. Okay. Minus 1 over 2 will cancel the first two, but you see I'm still left with the third one, which has a C and a D in it. So that's not great. So what's that? That's 7x plus 2, isn't it? Yeah. So actually, if I use, if I use minus 2 over 7, then the second and the third one go, and I can find the A. Okay. So I'll need the calculator, or you know what? Maybe I'll just type it in here. It'll be just as handy. Okay. Can you just call out this black line here that I just wrote? So it's 16x squared. What's next? 65x plus 18 equals A 2x plus 1 squared plus B 2x plus 1 7x plus 2, is it?
Yeah.
Thank you. And then finally plus C times 7x. Oh yeah, okay. Cx plus D times 7x plus 2. It was like this, wasn't it? Okay, so what did I make x equal to at the start in my last one? What was it? Minus 2 over 7. So if you put in minus 2 over 7 and simplify it down, you'll end up getting this, because the x is known and the b and the c, these two cancel. So I just can solve this now for a. So a is 4 when you sub it in and simplify. So if you want, you don't have to write the work down, you can just write down a equals 4. So when you substitute in this, therefore a equals 4. So we have the a. Okay. So let's go back. I'll just delete this. So I know that the a is 4. That's good. Okay, what should I choose next for x? Yeah, if I choose minus 1 over 2, then the first one goes, the second one goes, but I'm left with this. But let's see what happens anyway. So if I choose now x equals minus 1 over 2, what happens? So x equals minus 1 over 2. I get this here. Now you see, this is a problem. Can I get C here? No. Can I get D here? No. But remember I said at the start, I know one of them should be 0. So we have to actually split our question into 2 now and consider both possibilities. Either C is 0 and D is not, or D is 0 and C is not. So let's look at both possibilities. So I'll make C 0. So if I make C 0, then D will be 7. So here, choose the C to be 0. That would make the D equal to, what did I say? 7. Or, I could have chosen the D to equal 0, and therefore C would equal. So now already I have 2 possible answers to consider. So if I go back here, so again I repeat the process. X is minus a half. Oops, that's ugly. Simplify. And this time now I choose the D to be 0. So this time now D is 0. And then what do I get for C? I get C is minus 14 when I solve it. So if I choose D as 0, then C would have to be minus 14. So now I have 2 answers. I have A, C, and D. What's left to get? B. So I'll just split my page in half now. So the first possibility is A is 4, B we still don't know, C is 0, and D is 7. And the second possibility here is A is 4, B we don't know, C is minus 14, and D is 0. Yep. Here, if I choose this for x, then A works out to be 4 from this equation. Yeah, but the thing is I just used the program to get it, so I know it was impossible for me to make a mistake, unless I typed it in wrong. So I think you made a small slip in your algebra. So I'm just going to move on and let you find that. Yes, I'll move on. Okay, now the nice thing here is, because there's only one thing left I don't know, in fact I can make any choice for x, because I know A, I know C, I know D, I don't know B, so I could just choose, for example, x equals 0. X equals 0. So if I choose x equals 0, I'd get 18 equals A, which I know, times 1, plus B, which I don't know, times 2, plus C, which is 0, D, which is 7, times 4. I'm just subbing in the information back here. Likewise here, I can do the same thing. X is 0, I get 18 equals A, which I know, 1, B, which I don't know, 2, C, which is minus 14, and D is 0, and then here, so what number is that at the end? That's a 2. Did I write 4 here? Sorry, that should be a 2 here, and a 2 here. So now I can get B from both. Yep. Well, now you have 2 choices for B. Yeah, because of the 2 choices for C and D. So in this one here, what do I get for B? Let's see. That's 14. Is that right? 14 minus 14. Yeah, so B is 0. And then what choice do I get here for B? This would be 14 plus 28 equals 2B. So B is 16? Yeah. Is that right? Did I do that right there? No, can you check it? Sorry. For here, B? B is 21, yeah? You sure? I'm sorry, did I do this one right then?
Yes.
B is 0 then. So now we have 2 answers. First one, A equals 4, B equals 0, C equals 0, D equals 7. A equals 4, B equals 21, C equals minus 14, and then this last one here, D equals 0. Okay. Now I just want to double check all my numbers here. Just go back up here. This is correct. And then here I'm putting in X is 0, so that's A, which is correct. Then that there is 2B, which is correct. And then C is 0, D is 7. Oh, hang on, sorry. This is 7 multiply 2. 7 multiply 2. That should have been a 14 there. And then if I put in X is 0 here, that's 18. That's right. This one here is 4. B we don't know, that's a 2. And then C is minus 14. D is 0. But the X is 0, so it's just 0, 0. Oh, so that's gone. Sorry. D is 0. And X is 0. So this here is 0. So this, actually, I shouldn't have written that at the end there. Okay, let's just fix these. Okay, what do I get for B here now? Is it 7?
Yeah.
Yeah, and what do I get for B here? Okay, what do I get for B here? Can you check on your calculator, please? I'm waiting for you. Tell me what you get for B. What is it? Yeah, okay. Minus 42. Yes, did you get minus 42?
Yeah.
Yep, okay. So I'll just fix this here. Okay, so now we have 2 answers. Joshua, would you like me to kick you out? You're distracting me. And you too, Tal. I just need you focus on this. This is a difficult question, isn't it? So I need your full attention. Joshua, you are very close to being kicked out. And you too, Tal, not far behind, okay? Just focus here. Okay, so we have 2 possibilities here. The first one, A, B, C, D, and second one, A, B, C, D here. Now, in fact, the only way really to check for 100% certain is to add the 2, to look at the 2 answers and see which one gives you back the question. Okay? So if you were to look here, you would have A, B, C, and D. A, B, C, and D. And what was my first factor, please?
Minus 2 over 7.
No, the factor.
7x.
7x. And then the second one? 2x plus 1. And then 2x plus 1 squared. With pluses here. Okay, and then here 2x plus 1. And then here 2x plus 1 squared. So the first possibility is 4 minus 42 and 7, or 4, 7, and then minus 14x. Okay. Okay. And like I said, the only way now to check it is to add these, to put them all together and see which one you get. Now in the exam, we don't actually have to worry about that in the exam, because the exam question will tell us which one to choose. Because as you can see, this is already a very long question. So there will be something in the question that will let us choose, yeah? Which one here? This here should have been this one. Is this 0? Is that what you're saying?
That's what we were discussing with George.
Okay, thank you. So this one here is 0. I don't know why people get the wrong answer when they have calculators.
No, it's at the end of the back. The answer is just a full fraction. There's no...
Wait, hang on. Are you telling me that... Just give me a calculator. Yes. Are you telling me that B works out to be 0, or are you telling me that it should be 0?
I don't know, according to the answer. It should be 0.
I'm not ready even to look at the answer yet. Okay?
That's what you wrote. 18 minus 4 minus 14.
Yeah, hang on. Hang on, Paul. I don't need your help right now. I just need people listening. So, is the B here, it actually did work out to be 42. You're not telling me that 42 there was wrong. Now forget about the back of the book for the moment. Is it 42? Yes. That B should be 0 there, not 42. 7 multiplied 2. Oh yeah, okay. I put in a 14, didn't I? Did I replace the 2, or did I replace both of them with 14? It's the one at the back. The C is 0, the D is 7. Yeah, so just to be clear, sorry it doesn't look like that. I was saying that all of this was 14. Yeah. Yes, if that was only the difficult part in the question. Yes. Okay, so B is 0, which is good, because then this piece is gone. So now we have 4 over 7x plus 2 plus 7 over... That's you, Joshua, isn't it? Is that yours, Joshua? Get out, please. Just get out now, please. Just leave. Leave everything on the table, just get out. And I'm going to continue when you're gone. Hurry up. No, please stop looking at the back. I'm getting to the answer now. So we have two answers now. 2x plus 1 and squared, or 4 over 7x plus 2 plus 7 over 2x plus 1 minus 14x over 2x plus 1 squared. Yeah, no, I know. Yes, I got the answer at the back. How surprising.
You didn't believe me.
No, I didn't believe you. I was telling you to wait and be patient.
No,
that's all.
you didn't believe me.
Yeah, okay, well that's between the two of you. So look, we have two answers here now. In the exam, the question will inform us of which answer to choose. And in fact, when you look at the back of the book, you'll see that it was this answer at the back and not this one here. If the question doesn't tell you which one to choose, you have to go through the trouble of checking which is the correct one. So you have to put these two together, okay, and then you have to put these three together and see which one matches the question. In fact, it turns out to be this one here. Okay? But like I said, in the exam, usually there's something in the question that informs us which one to choose. Okay? Now, just before we finish now, there's just something else to show you. I won't fully do the question, but I just want to set up I. So really quickly now, just part of I. Okay. Can you factor... Oh, well, whose calculator was this? So can you factorize that cubic for me, please? What do you get?
(3x plus 1)
Times 2. Yeah.
and then this minus 2 plus 2i.
Yeah, so if you were to factorize this cubic, you get only one solution. But there should be three solutions, or at least there should be something else here. So how can you get the other factor if you only have one of the factors? Well, we're back to semester 1. So when you have one factor, what is it? Long division. When you have one factor of the cubic, if you divide it, you get the second factor. So what you do is you do 3x plus 1 divided into the cubic, and then what do you get here? A quadratic. Now, again, you do the long division. I'm going to skip that and just get the program to do it for me to save time. You know how to do long division. You've done it in semester 1. What is the cubic? Can you just read it back to me, please?
Minus 3x cubed.
Minus 3x cubed.
Minus 13x squared.
Minus 13x squared.
Minus 28x.
Minus 28x. Minus 8. Okay, so if you do the long division here, you'll get this quadratic out from the long division. Minus x squared minus 4x minus 8. So that's minus x squared minus 4x. What did I just say? Minus 8, was it? Yeah.
It has no roots.
And it has no roots, absolutely. Yeah. This is why I wanted to do this one. It has no roots. So now, yeah, okay. So what do we do here in this situation? Well, it's exactly the same. No, it has an answer. The first one is a over 3x plus 1, and then the second one, you can't simplify it. It's a bit like the repeated root, in that there's a quadratic in the denominator. So what should I put here in the numerator? bx plus c. Okay? And I do not expect the b or the c to be 0. I do not expect this. If it is 0, that's just by accident, but I have no expectation that the b or the c should be 0. Okay? In fact, I don't expect it to be 0. So I cannot say one of these should be 0. What's the next step? The next step is we multiply by the cubic here, and we continue to find our ABC. And then that's it. And there's no choices here. You'll just get one value for A, B, and C. Okay? So in fact, this one here is a little bit easier than my last example because there's no choice. You don't expect this to be 0. I do think, however, in this question, the second method I show you actually will be easier than the first method of choosing the x's. Until I do it, I can't know that for certain, but when you try it yourself or one like it, I think the second method is easier here. I think the problem with the first method is it's too difficult to find an X to make them all cancel, okay? So just keep that in mind. Keep a note for that one. Second method, I believe, works better here for this one, okay? Now you see, these are difficult, and I think this is probably new for most people. Yeah? So it's your responsibility to practice and study them at home. Your responsibility. Okay, we'll leave it there, so.